Hello everyone, welcome to Royal Tutor Online platform. We say a big thank you to all of our subscribers. If you are joining for the first time or you've not subscribed before, kindly click on the subscription button so that you get notification whenever we post new videos. Yeah, today we want to talk about number sequence. Yes, number sequence is a very broad topic. We may not be able to finish it in one video, but at least we'll cover a lot of things in this video. Stay tuned. Okay, so number sequence. Generally, when you talk about sequence simply means array of numbers. When you put number in array, what do I mean by that? When you put number in a kind of a pattern, for example, you just write 2, 4, 7, 6, 3, 5. What am I doing? I'm putting numbers in array. This is simply called number sequence. Most of the time, they are separated by comma. And then these three dots means that it continues. So this is an example of a number system. Number sequence rather. Number sequence. We have different kinds of number sequence. We have some that they just follow a kind of pattern of which they are going to give us the definition that it follows. We have some that they are called arithmetic sequence. I'm going to explain that as time goes on. We have some that are called geometric sequence. We have some that are called Fibonacci sequence. A lot of them, but I'm going to touch these three in particular. Arithmetic sequence, geometric sequence, Fibonacci sequence. I'm going to touch the three of them in particular, and I'm going to explain in details what each of them means. But generally, when you talk about sequence, there are times that they give us definitions of sequence. There are some things I want us to establish when it comes to sequence. The first thing is number of terms. Number of terms. This is most of the time represented by n. Either you're talking about arithmetic or geometric or Fibonacci, most of the time, number of terms is represented as n. I want us to also recognize last term. Last term. Most of the time, the last term is represented by capital L. But sometimes we call it nth term. Sometimes we call it nth term. And at the same time, we can call it Tn. By the time I take each of them one after the other, I will explain what this means. But you are going to see something like this as we go on. Last term, which is capital L, which is sometimes referred to as nth term, which can also be Tn. Then there is another one, first term. Just like the name, first term, it is the first number you see. If you check the array of numbers we have here, 2 is the first number we see. So 2 is the first term. So first term is most of the time represented by small letter a. So if you come here now to come and explain these things, for example, number of terms. Now number of terms means how many numbers are there? 1, 2, 3, 4, 5. So let's say this stops here. Let's say it doesn't continue. So how many numbers are here? That's number of terms. You have 1, 2, 3, 4, 5, 6. So there are 6 terms in the sequence. Sequence is array of numbers. Now, when you talk about number of terms in the sequence, you mean how many of these numbers are there. Then when you go to last term, now last term in this case is 5. That is the last number in the sequence. So last term is 5. And when you come to first term is 2. So every sequence has those three things. It has the first term, it has last term, it has number of terms in every sequence. Whether the general one, whether the arithmetic one, whether geometric, whether Fibonacci sequence. Whatever sequence you want to talk about, it has number of terms, it has last term, it has first term. Okay, so let's dive in straight into what we want to do. I want to start the first one, arithmetic progression, which is also arithmetic sequence. Sometimes it's called progression, sometimes it's called sequence because it follows some kind of pattern. So arithmetic sequence now, the first one. Arithmetic sequence is a kind of, I know we already said sequence is an array of numbers. So arithmetic sequence is a kind of array of number in which the difference between every consecutive term, take note, difference between every consecutive term is the same. It is constant all through the sequence. Consecutive terms are terms that follow themselves. So when you find the difference between any consecutive term, it is constant all through the sequence. For example, we have 1, 3, 5, 7, 9, 11. So if you check the difference between these terms, consecutive terms means terms that are following themselves. 3, it's always the last minus the first. That's 3 minus 1, 2. You check the difference between this 5 minus 3, 2. You check the difference between this 7 minus 5, 2. You check the difference between this 9 minus 7, 2. You check the difference between this 11 minus 9, 2. So you see that the difference is constant. So whenever you have a sequence like this in which the difference between every consecutive term is constant, then the sequence is called an arithmetic sequence. It's called an arithmetic sequence. It's called an arithmetic sequence. Whenever the terms, when you find their different consecutive terms, you get the same answer. It's called an arithmetic sequence. And these answers, these ones that you've gotten, they are called common difference. Common difference. So you can say the common difference of this arithmetic progression is 2. Don't forget where we started from. Okay, I think I think it already. For every sequence, you have the number of terms, you have um, first term, and you have last term. Then for arithmetic sequence, you have what we call common difference. What is the common difference? The positive, it's not necessarily positive, but the difference between two consecutive terms, which is constant, or which is what you check for to identify that it is an arithmetic progression. So this difference is called the common difference, and it's always the last one minus the first one, the last one minus the first one, the last one minus the first one for every pair that you pick. So to be 9 minus 7, you have to. 11 minus 7, you have to. So if it is common in the sequence, you say the sequence is an arithmetic sequence. Now I'm going to teach us some things. I'm going to teach us when they ask us to find number of terms of any arithmetic sequence. There is a shortcut. There is a way we can find the number of terms of any arithmetic sequence, because sometimes you will not be able to count them like this. Easily you can get the number of terms for this. Easily the number of terms here will be 1, 2, 3, 4, 5, 6. Very good. 6. But don't forget to identify that this is the first term. Verify that this is the last term. Based on what I explained earlier, first term is the first number in the sequence, while the last term is the last number in the sequence. I will take that again. First term is the first number in the sequence, while the last term is the last number in the sequence. So if they ask us to find the number of terms, you can simply use this formula: number of terms is equal to the last term minus the first term divided by the common difference plus the 1. Okay, I'm going to use it for this one before I give us one that is very big. This is a very simple one, you can easily count yourself. But I want to show you that with this formula you get the same thing. Number of terms is always the last term minus the first term divided by common difference plus 1. Now let's see if it's going to be correct. The last term here is 11 minus the first term 1 divided by common difference. What is the common difference? We said the common difference is 2, then plus 1. So if you do this, you have 11 minus 1 is 10. 10 over 2 plus 1. This is going to give us 5 plus 1, which is 6. Of which truly, if we count, we have 6 terms. 1, 2, 3, 4, 5, 6. Mind you, this formula can only work for arithmetic sequence. I will say it again. The formula can only work for arithmetic sequence. It won't work for geometric sequence. At the same time, it won't work for Fibonacci sequence. It can only work for arithmetic sequence. So all you need to do is last term minus first term divided by the common difference plus 1. Now, for example, if you have a question that says that how many numbers are divisible by 3 between 1 and 100? I'll repeat the question again. How many numbers are divisible by 3 between 1 and 100? It won't be easy to count just like this, because if you want to list out the numbers that are divisible by 3 between 1 and 100, you start with 3 itself. 3 is divisible by 3. You go to the next one, which is 6. You go to the next one, which is 9. You go to the next one, which is 12. You continue like that until you get to 99. So at 99, you are going to stop, because that is the last number divisible by 3 between 1 and 100. So So it is not easy to count one after the other, one, two, three, four, just like we did for this. So this formula is going to help us. Number of terms, number of terms is equal to last digit minus first digit divided by the common difference plus 1. Now let's see, from the sequence that we have, what's the first digit? I told you the first term, which is the first number on the sequence, is 3. The last number is 99. Then the common difference is the difference between two consecutive terms. So let us see, 6 minus 3 is going to give us 3. 9 minus 6 is going to give us 3. 12 minus 9 is going to give us 3. So we can see clearly that the common difference is 3. Okay, so to get the number of terms, of which you can also represent as n, I said it earlier, the number of terms can be represented as n. N is equal to the last digit, which is 99, minus the first digit, which is 3, divided by the common difference, which is 3 plus 1. Okay, so you have 96 divided by 3 plus 1. So this is going to give us 32 plus 1. This is going to give us 33. So if you take your time to count one after the other, you see that there are 33 numbers between 1 and 100 that are divisible by 3. I want you to try one. I will give you one to try. All you need to do is just to pause the video, do it, and then come back online to see if it's correct. So how many numbers between 1 and 101 are divisible by 4? How many numbers between 1 and 101 are divisible by 4? You can pause the video now, then you play it after you are done. Okay, so I believe you must have touched this now, you must have gotten your answer. So let's see if the answer is correct. So the first one is going to be 4. You have 8, you have 12, you have 16. You can continue like that, but when you get to 100, you stop because that's the last number divisible by 4. Okay, so you have that your first number is 4, your last number is 100, your common difference is 4. So I believe I've mentioned it in two places, that's why I'm not mentioning it again. So you have your number of term, which is last term minus first term divided by common difference plus 1. Okay, this is just having 96 divided by 4 plus 1. So if you divide, you should have 24 plus 1, which is 25. So there are 25 numbers that are divisible by 4 between 1 and 100. If you get the answer right, well done. If not, you can always watch this video over again, and I'm very sure you'll be able to solve the question. So don't forget to click on the subscription button because we still have other things to touch in arithmetic sequence. We have not even started anything in geometry sequence. We still have Fibonacci sequence, and I don't want you to miss any of these lessons. Okay? So if you find the teaching informative, you can click on the like button. Also, I expect your feedback on the comments. In the comments box. Thank you very much. See you next time. Bye.